Advantages of combined use of crop hooks and sublaminar wires as the upper foundation of long fixation from the thoracic spine to the pelvis in osteoporotic cases. A finite element analysis of the proximal junction stress. Adult spine deformity has become one of the most common spinal disorders in the aging population. It carries the possibility of low back pain and interferes with daily activities. Surgical treatments have improved the quality of life for patients with AS adult spinal deformity, but proximal junctional kyphosis (PJK) has become a more common problem following spine fusion surgery. Although the placement of downgoing transverse process hooks (TP hook) in URV has often been discussed as one of the techniques to prevent PJK. We felt that this was insufficient in terms of mechanical strength. Therefore, we have considered the following method as the uppermost foundation: claw hooks in UAV and facet hooks in UAV-1. The combination of the claw hooks and sublaminar wires keep good alignment. The aim of the study was to compare the biomechanical stress at the proximal junction aspect between all pelvic screw construct and the uppermost claw hooks fixation method. FE models were constructed from the patient's diagram data and analyzed with mechanical finder software. From the intact model from C7 to pelvis, we construct two types of fixation models: all pelvic screw fixation model (PSF) and low PS density fixation model (LPF). In LPF model, the bilateral claw hooks, the combination of the bilateral downgoing transverse process hooks and facet hooks, were set at T2 UIB, facet hooks at T3 UIB-1, sublaminar wires at T4 to L1, and PS at L2 to S1 with S2AI screw fixation. We also created the lower thoracic spine to pelvis fixation model. In the PSF, the PS were set from T10 to S1 with S2AI screw fixation. In the LPF, the claw hooks were set at T10, sublaminar wires at T11 to 12, and PS at L1 to S1 with S2AI screw fixation. In LPF model, the bilateral claw hooks were set at T10, sublaminar wires at T11 to 12. We applied 100 Newton at the upper end plate of the C7 vertebra, followed by the 10 Newton meter friction moment in the upper thoracic spine to pelvis fixation model. Also, we applied 400 Newton at the upper end plate of the T8 vertebra, followed by the 10 Newton meter friction moment in the lower thoracic spine to pelvis fixation model. The contact conditions were defined on the interface of PS at UAB plus two vertebral body in the PSF model and interface of all hooks to vertebral bone in the LPF model. We analyzed the bone builder stress at the ventral half of the vertebral body at UAB, UAB plus 1, and the disc at UAB, UAB plus 1. We included 10 patients in the study. Half of them had osteoporosis and the others had non-osteoporosis. The ligaments were described as truss ligaments. These were results of the upper thoracic spine to pelvis model. There was no significant difference between PSF and LPF in the bone middle stress in non-osteoporosis model, but the stress of LPF at vertebral body and these were significantly lower than PSF in non-osteoporosis model. In same, the results of the lower thoracic spine to pelvis model, there was no significant difference between PSF and LPF in bone middle stress in the non-osteoporosis model, but the stress of LPF at vertebral body and disc was significantly lower than PSF in osteoporosis model. Presumptive case. In non-osteoporosis model, there was no significant difference between PSF and LPF model, but the stress at the vertebral body and disc was lower in the LPF than PSF in osteoporosis model. We set the claw hooks as a combination of inferior articular process hooks and downgoing transverse process hooks, which can firmly hold the posterior components of the vertebral body in 3 dimensions, and at the same time decrease the stress at the vertebral body. Conclusion. In osteoporosis, the bone middle stress was significantly lower in LPF than PSF. The claw hooks stabilize the vertebral body at UAB firmly, and sublaminar wires reduce the load transmission from the fixed spine.